Hey everybody, this is Stephen Ramsden, the director of the Charlie Bates Solar Astronomy Project. We're super excited today because we just got the brand new Meade 2-inch white light solar wedge. It is awesome, dude. It's got all kind of cool stuff. 1 1/4 adapter, comes with a polarizer inside that you can adjust and lock into place. Very cool, very cool. The click lock, which makes it much easier to put in eyepieces and cameras and things. Click lock plus the click lock tightener, etc. There we go. And of course, the standard Herschel wedge, not William Herschel, but John Herschel, the sun, invented the white light wedge. It's got this cool finder on the back that lets you find the sun, and it's an awesome product. We are going to try it out shortly. First thing we're going to do is use our double stacked Coronado 90mm filter on the Skywatcher 6-inch Esprit, and we're going to check out some H-alpha sun right now. So stay tuned. Here we go. Thanks for joining us, by the way. Our website is solarastronomy.org. We're sponsored by the fantastic folks at Coronado Solar Telescopes, Celestron, and Skywatcher USA. Rainbow Symphony provides all of our solar viewing glasses that we give away. Got to pay the bills first. Here we go. Screen share. Yes, this is a Star Trek beanie. Star Trek Discovery rocks, man. All right. So what we're looking at today is the live view from downtown Atlanta. Let's get the exposure adjusted a bit. Just 1 second. Let me switch back over to that again. Technical difficulties. All right. We've got a pretty good layer of cirrus overcast today, but we can overcome that with a little camera adjustment. And I think the clouds are pretty cool myself. Everybody's whining and complaining because there's no sunspots, whatever. The sun is always awesome. Every day, it's got all kind of cool features you can check out and record. As soon as these cirrus clouds go by, we're going to be getting some pretty awesome prominences and filaments on the sun today. Go ahead and get that centered up for you. I'm using Astro IIDC software on an iMac, which is what we always use in our outreach program. And we've given away over 50 of these complete setups so that other people can use the same software. It has a really cool live preview feature where you can color the live preview to whatever color you want. So let's try that out real quick. As soon as I get it recentered, my guider's acting up because the clouds are pretty thick right now, but they're clearing shortly, so don't worry. All right. Let's get some color on this bad boy. What color do you want? Well, H-alpha is as red can possibly be, so it would be this color normally, which is pretty difficult to see. So I'm going to change it over to a cool orange color just to make it easier to see, maybe even yellow. Let's go with orange and see what happens. Tangerine. Okay, so we've got a pretty cool filament up here. And as soon as, like I say, the clouds clear off a bit, we're going to see some pretty good prominences on the 4 o'clock position and the 7 o'clock position on the sun. I'm happy with it. Of course, I'm happy with the sun every day. I'm going to go ahead and mute the microphone for a bit so you can enjoy the view without having to listen to me. We are waiting for some cirrus clouds to pass by. Currently, we're using a Skywatcher 6-inch Esprit refractor and 2 Coronado 90mm H-alpha etalons on the end of it, and a BF30 blocking filter from Coronado. Coronado makes fantastic scopes for visual and imaging, and we highly recommend them. So there's not a lot to see, especially with the color turned on. So let me turn off the color. We might get a little bit better resolution. There you go. It's a little easier to see the features. This is a big solar prominence that's, I'd say, probably 90,000 miles long from here to here. And that's a cloud of plasma that's floating over the surface of the sun in the chromosphere. It's a little bit cooler than the surface, and hence it has that darker color. Everything in astronomy is colored based on its temperature, nighttime or daytime astronomy. The cooler it is, the darker it is. Over here and over here, there are some really good prominences, but they're hard to see with the clouds. So the weather forecast says that the cirrus should be blown out of here very soon, and we will have a beautiful view of the sun. It was beautiful 10 minutes ago. It's a little bit cloudy now, but stay tuned, folks, because this is an awesome view of our nearest star. Speaking of our nearest star, it's 875,000 miles in diameter, comprised of 74% hydrogen atoms, 24% helium atoms, and 1% everything else on the periodic table up to uranium. It's made of the same stuff that we're made of, and the same stuff that our solar system is made of, because we were all formed from the same nebula. The way it's powered is really cool. Gravity is forcing all this hydrogen together. And at the core of the star, the pressure is intense, really, really high pressures. And of course, the temperature is directly proportional to pressure. So what you get is a gigantically, highly compressed ball of hydrogen in the center of the sun. And when it produces temperatures of 27 million degrees or hotter, hydrogen fusion begins. The hydrogen atoms are fused together to form a brief state of beryllium, and then a couple of helium isotopes, and then they form a stable helium atom and eject 2 protons to continue the cycle. It's a chain reaction that occurs inside the sun's core, based solely on Mother Nature and gravity. There's no dudes up there working in the control room pressing buttons or anything. It's all solely done through physics and nature. And that's one of the reasons why I love it so much. It's a floating classroom available for anyone to study, and you don't need very expensive equipment to check it out or share it with a bunch of kids at schools or the public. Meade puts out Coronado solar telescopes, and now they have a white light wedge also, which we're going to put on here in just a minute. And they make it available to use for astronomy outreach anytime you want, or just for fun for you. It's a great way to spend time with the family outside. And you can get some pretty cool images of a star. And this is indeed a star. This is what a star looks like. And this is the chromosphere of the star that we're looking at right now. If you ask me, it's awesome. Of course, if you ask me, pretty much everything's awesome, because I'm a really positive person and I like to stay positive. Life is too short to be mad. I'm going to go ahead and mute it again and stay tuned while the clouds clear up. By the way, we're coming to you from downtown Atlanta, and all those noises around you are busy urban life. You don't have to be out in the country to use solar astronomy gear. It doesn't really matter where you are, as long as you can see the sun. It's a great hobby, and I strongly suggest you get into it. Let me try to get this thing centered again for us. Oops. Let's try that. And if we get any viewers, I'll open up the chat link to get in here and join us. Usually people are at work or whatever when I'm doing this, because it's daytime, and they view it later on YouTube. But this is our star. Notice down here there's a beautiful prominence right here. There's one over here also. I turn up the gamma a little bit, or the camera sensitivity. You'll be able to see them better. All that glare is coming from the cirrus cloud layer that's in front of the sun. I'm going to mute it for a few minutes and everyone enjoy the view. Okay, so we're currently taking a video run of 600 frames through our point gray camera. And stack that and put it on Facebook shortly. A lot of cool prominences around the edge. This is a great view of the hydrogen alpha chromosphere just above the photosphere of the sun. Something interesting here is that the sun is getting closer every day, or we're getting closer to the sun every day, and it will not completely fit in the field of view of this camera any longer. And during the middle of the summer, when we're furthest from the sun in the northern hemisphere, the entire sun easily fits on this chip. But now that we're getting towards winter, around December 21st, we'll be very, very much closer to the sun, almost 1,000,000 miles. And the sun no longer fits on the chip. Yes, we're closer in the winter in the northern hemisphere. So now what we're going to do is put in the Meade white light wedge, 2-inch Herschel wedge. That's John Herschel and not William Herschel. And we're going to check it out, take some images, and I'll do a live broadcast here on it. But unfortunately, this is a live broadcast, so you have to wait while I swap things out. So everybody be cool, and I'll be right back. First thing we're going to do is take our camera and put the trusty number 56 green filter. This is a Meade Series 4000 filter. We're going to screw that on here, and that cuts out a lot of the light pollution and gives you more of a narrow band image of the sun, which is much cleaner and easier to focus, especially needed today on a day with crappy seeing and cirrus clouds. So we'll stick that into the wedge, lock it in place, and we are ready to stick this camera into our telescope. So hang on, we'll do that. Taking out my hydrogen alpha BF30 blocking filter, sticking the wedge into the scope. So I can turn the camera this way so you can see it. There it is. The wedge is here. I've got it tilted at an odd angle. There you go. It's that way, but I've got it tilted so that it lines up with the axis of my telescope. Now I'm going to run around here and pull off the hydrogen alpha etalons off the end of the scope. Pull them out of 90mm etalons, because you can't take white light with hydrogen alpha etalons. So everybody stand by. It's a very delicate thing to do, because what you don't want to do is drop the 2 etalons, because they're $5,000 a piece. And yes, I have done that before. It makes a terrible sound on the concrete. So, but hang on. Won't be long. The trick is not to get in a hurry, because as soon as you do, you will drop it. Okay, so the etalons are gone. And we're now getting a white light feed into the scope. Let me wipe off the lens a little bit. By the way, I'm using the CaK solar guider on this telescope, like I always use. It keeps the sun perfectly centered, supposedly, and it does a great job. So let's see if we can get it focused. I will share the screen again. It's out of focus now, but we'll get it focused here in just a second. The red indicates more exposed pixels in this software, which is very handy. So let me me see if we got enough back focus here to get this thing. Oh, yeah, we do. Cool. And there we go. A beautiful image of a spotless sun. But don't fret, because the spotless sun is still super cool. Let's get it back in the middle. And there we go. This is our sun in white light. Try to get it focused a little better, maybe get some granulation. There we go. Oh my goodness, man, what a beautiful image. Let me turn on some colors so you can see it better. Ooh, there was something just went by. Satellite, maybe? You see stuff passing in front of the sun all the time. Airplanes, satellites, bugs, birds, hands. Let's turn on some more natural color here so we can enjoy it. How about that? Of course, when you say natural color, the sun is white, as it's a combination of all wavelengths. But people like to see it in yellow for some reason. So here we go. It's now in yellow. And this is what our nearest star looks like behind some cirrus clouds through a Meade 2-inch white light wedge and a 6-inch refractor from Skywatcher USA, the Esprit 6-inch refractor. Unfortunately, there's no sunspots today, so there's not a lot of contrast in this view, but you can clearly see granulation all over the disk. And it's an incredible view. Just to think that this giant ball of hydrogen fusion going on in the center of our solar system is the most important thing in the universe to our existence as a species and a planet. Of course, most people know nothing about the sun. They don't care. They're more worried about the football game this weekend or what's going on in the Kardashians' house. But we're trying to get people to know more about nature and the sun through our nonprofit, the Charlie Bates Solar Astronomy Project. I think it's critical for our species' survival. So, there we go. And you can do this yourself in your driveway with almost no problems at all. A lot of people try to make this hobby out to be difficult or hard or something. There's nothing hard about pointing a solar safe telescope at the sun and taking movies or still pictures. It is extraordinarily easy to do. And I can have anybody on this audience taking photos, top quality NASA type photos of the sun in less than an hour. All you have to do is have the right equipment, which you can get from Meade, Coronado, Celestron, and Skywatcher. There's other companies out there too. Set it up, press a few buttons, and boom, you're a solar imager. Nothing hard about it, nothing difficult about it. That's the first time I've ever seen that Meade white light wedge. I took it out of the box at 1:07 p.m. Eastern Time. It is now 1:25 p.m. and I am taking video of the sun's photosphere using that product. That's how easy it is to use. Herschel wedge, developed by John Herschel, son of famous astronomer William Herschel. And it's basically just a really crappy mirror that doesn't reflect much, about 1/10,000th of the sun's light. And it's used to observe the sun safely. In my opinion, it's the safest way to observe the sun in white light, because it's very difficult for little hands to get up there and disassemble it. I'm a big fan. We don't use the aperture filters in our program because I've had too many students poke their fingers through them, and that tends to hurt your eyes or your telescope. So we just don't use it anymore. We use white light wedges only. Meade white light wedges only. to get one of these for yourself and you already have a refracting telescope, they don't work on reflectors. They work on refractors only. Go to Meade.com, press a couple buttons. It'll be on your doorstep in a couple days. And then you can get online and brag about what a great imager you are too. Or you can start your own community outreach program. Teach other people about the sun. I'm going to mute it again and let's just enjoy the view. Next up, we're going to go with a calcium K wedge, if you will, a calcium K diagonal. The mailman just came by with a post for this morning, and I was giving him a little bit of solar outreach. So I'm back with you now. We are looking at the sun through the new Meade 2-inch Herschel wedge. It's got a great polarizer built into it. And if you use it visually, you should have a second polarizer on the bottom of your eyepiece. And the way that works is you turn the eyepiece with the polarizer on it until you got the right brightness. And then you can look at the sun all day long. For imaging, I don't use the polarizer. I just go with the standard brightness And I use a green number 58 filter. And that's what we're looking at now. No sunspots today, but it's still a gigantic ball of hydrogen fusion. It's probably not transferring on the internet very well, but you can clearly see granulation all over the surface of the photosphere. This is an excellent product. I highly recommend the Meade White Light Wedge. In a moment, we're going to take it out and go over to calcium K. Check that out. There's some more clouds coming in. I love the clouds. They look really cool. I don't get excited about it messing up my image. I'm going to stop the recording here. Okay. And we'll just watch some cirrus clouds go by the sun. I think this is really awesome. Sometimes the clouds also show the granularity better on the sun. It's like putting a second filter up there. I'm going to go ahead and turn off the false color so you can see the actual color of the sun through this telescope. There you go. That's the actual view, raw view through the camera. Granulation is clearly evident all over the surface with this wedge. And all those sounds behind me are the sounds of the city. I live in the middle of downtown Atlanta, and we're looking at the sun in between a couple of tall buildings. Having a good time. Life is good. Solar astronomy is a great hobby. I highly recommend it. It's very easy. That's the mailman pulling off with a satisfied feeling that he's seen the sun. Well, look at that granulation, man. What a great view. Folks, this is the Meade 2-inch Herschel wedge they just came out with. Very inexpensive. Works on any refractor. Great for visual or imaging use. We're running it now on a Skywatcher 6-inch Esprit refractor with a a Meade number 58 green filter. And this is what it looks like. It's fantastic. If you remember from the beginning of the live broadcast, we had the hydrogen alpha scope set up with the Coronado 90mm filters. And there was all kind of chromospheric features visible for viewing, but you can't see any of those in white light. And the reason for that is we're seeing the full spectrum of the sun, all visible light colors. And the yellow and the green is most of the sun's output, and that strongly overshadows any other wavelengths. So when you have the yellow or the green coming through, or both in this case, you can't see any other wavelengths. All those features are still there. They're just not visible. It's like looking at a tiny LED light standing in front of the bright lights from a semi-tractor trailer. You just can't see the smaller light. The bright light completely overshadows it. Fantastic product. I strongly recommend it. Also this evening, if the clouds hold out, we're going to be broadcasting live nighttime astronomy, or sissy astronomy as I call it. Well, look at that view. That is a really, really good view. Fantastic. Meade has scored with this product. This is a great, inexpensive way to get into solar astronomy or solar astronomy outreach. All right, so if everybody will stand by, I'm going to swap over to calcium. We're going to look at 393 nanometer wavelength from the sun. It's going to show you the upper chromosphere. So hang on a minute, and here we go. Sorry about that. I understand I was muted the whole time. It was a very interesting story. I'm sorry you missed it. So here we are, focused in calcium. Let me adjust the exposure. Boy, the clouds have cleared away. And there's our sun in calcium light, 393 nanometers. Very interesting. This light is produced by calcium atoms, which are very trace amounts in the sun's chromosphere. When those atoms are energized by the nuclear fusion in the core of the sun, they eject one of their electrons from the outer shell and become calcium-2 ions. And along with that ejected electron comes a photon at 393 nanometers. So what you are seeing are photons being ejected by energized calcium atoms in the sun's outer chromosphere. That's right. It's called CaK, or calcium K for short, and that has nothing to do with potassium. It's called CaK because it is calcium atoms, and they are creating an emission line at the K position on the visible light spectrum. So just like hydrogen alpha is called H alpha because it's creating an emission line at the alpha position on the spectrum as determined by the Balmer series. Calcium is producing an emission line at the K position on the spectrum as determined by Fraunhofer. All the little black lines in the spectrum of visible light all have names assigned by different research or different scientists. This is the calcium K line. Let's get an image. Again, all the brighter areas indicate hotter regions of magnetic activity on the sun. The darker areas are cooler regions. Oh, the wind is really picking up. Of course, when the wind starts blowing and you're using a giant telescope like me, your telescope becomes a sail and tries to sail away. The sun is barely fitting on the chip now because we're transitioning into winter here in the northern hemisphere. And close, of course, we get a great deal closer to the sun in the wintertime in the northern hemisphere. We're tilted away from it more, which produces the drop in temperature, but we're much closer to the sun in the winter. So this is what the chromosphere looks like in calcium K. And I'm going to turn up the exposure here in just a second and try to get some prominences in calcium K. Again, anybody listening to this, anybody out there can be doing this hobby in less than a week if you purchase the right safe equipment and cameras. It's not that big of an expense any longer, and it's a great hobby for you and the kids, you and the family, or just for you to go out and marvel at the majesty of our life-giving star, the sun. All right, let's turn it up, see if we can get some prominences. Really kind of crappy weather to try to get prominences because the cirrus clouds produce a lot of glare, but we'll see. See what happens. The red ball is produced by the software. That's just oversaturated pixels. And I'm trying to see if I can get any prominences of calcium. Doesn't look like it. Give it a second, look around. No, probably not today. The glare from the layer of cirrus clouds between my telescope and the sun is masking any solar prominences that might be visible in calcium K wavelengths. They're very, very dim. So any kind of disturbance like this layer of cirrus clouds just overshadows them completely. So let's go back to surface brightness. All right. And let me go ahead and give you the color version of this. Calcium K produces 393 nanometer light, which is actually outside of the generally accepted visible spectrum. So you may or may not see calcium K through a telescope. Some people can, some people can't. But this is a pretty close approximation of the color. Near ultraviolet, or purple, as we called it in high school. Again, we're using a calcium K module attached to the end of a Skywatcher Esprit from Skywatcher USA. This is a 6-inch refracting telescope, and I'm providing the image with a FLIR FLIR camera, formerly point gray, through Astro IIDC software on a 27-inch iMac in my driveway in Midtown Atlanta. Anybody can do solar astronomy anywhere. You don't need dark skies. You don't need any of that crazy nighttime astronomy stuff. Just get a telescope and a narrowband filter, and you are set to go, man. Notice how the atmosphere is really jumping around. Some people look at it for the first time and they think that's the sun's atmosphere causing all that. It's not. It's our atmosphere. It's the Earth's atmosphere between me and the sun. Anytime there's strong winds or a jet stream or a big wind differential in the atmosphere above you, it causes a great deal of erratic refraction of light waves. And that makes for this jumpy, bouncy appearance. Just imagine if you were in a swimming pool and you were trying to read a book in front of you. The water refracts the light so much in so many different ways that it's impossible to focus on anything. And that's exactly the same thing that's happening here. It's difficult to focus because the humidity and the wind is causing all sorts of various refraction patterns in the light. So while it's easier to see this than it would be a book in a pool, that's the same reason that the image is distorted. Again, this is Stephen Ramsden. I am the founder and director of the Charlie Bates Solar Astronomy Project, and our single goal is to turn community interest and social interest into astronomy interest. We feel like it's the only thing that'll save our species from extinction, save us from ourselves, basically. We need to get back to a science-minded culture, get ourselves into space and colonize another planet. And that's what we do. We are a nonprofit 501c3 headquartered in Atlanta, Georgia. We currently operate in 27 countries around the world. We're sponsored by Meade Coronado Telescopes, Celestron, Skywatcher USA, and our great supporters at Rainbow Symphony, who make the best eclipse glasses in the world. Man, what a beautiful image. I'll tell you what, notice how much sharper it is in this wavelength than it is in the long wavelengths. This is a much shorter, higher energy wavelength. You can penetrate the disturbance a lot better. What a view, let me tell you. Let's see if we can get some prominences now that we've got a little period of clear skies. I still can't really see anything. Very difficult to get the prominences when there's cirrus clouds. But they are there. It's not cooperating today, is it? There we go. There's a prominence there. It's a pretty good one. Yeah, there's a prominence up there. We can go ahead and take an image of that. That's good enough. This is the camera's exposure turned up real high so you can catch the prominences in near ultraviolet of calcium CaK. So we'll take an image here. I've got the gamma turned real low and the exposure turned real high. Normally, I can operate at just normal gamma with real high exposure with prominences. There's a lot of glare coming from the cirrus cloud layer. Okay. Let me adjust it back down to surface brightness. And there's the sun and calcium CaK. There's the sun's chromosphere and calcium CaK. Pretty awesome, if you ask me. And since you're listening to my broadcast, I'm assuming you are asking me. All right. So there we go. That was our live broadcast from Atlanta today, October 16th, Monday. This is a great hobby to get involved in. Strongly suggest it. And I'm Stephen Ramsden, director of the Charlie Bates Solar Astronomy Project. I appreciate you tuning in. The Meade 2-inch white light wedge is a big hit in my book. It works great. I loved it. Very inexpensive, and I highly recommend it.